Hi everyone, this is Srevathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. S.N.S. Rajlakshmi College of Arts and Science. So the next video is the computer system architecture. So first, what is computer system architecture? So computer system architecture is basically a machine that simplifies complicated tasks. It should maximize performance and reduce cost as well as the power consumption. So the different components in a computer system architecture are input unit, output unit, storage unit, arithmetic logic unit and control unit. So a diagram that shows the flow of data between the units is as follows. The input data travels from input unit to arithmetic logic unit. Similarly, a computer data travels from arithmetic logic unit to output unit. The data constantly moves from storage unit to ALU and back again. This is because stored data is computed and before being stored again. So the control unit controls all other the unit as well as the data. So next we see the computer units. There are input unit, output unit, storage unit, arithmetic logic unit and control unit. We will see one by one. First one is the input unit. So it provides data to the computer system from the outside. So basically it links the external environment with the computer. It takes data from the input devices, converts into the machine language and then loads into the computer system. For example, keyboard, mouse, etc. are the commonly used input devices. So next one is the output unit. So output unit provides the result of computer process to the user, that is, it links the computer with the external environment. So most of the output data is form of audio or video. So the different output devices are monitors, printers, speakers, headphones, etc. Next one is third one is the storage unit. So storage unit contains many computer components that are used to store data. It is traditionally divided into primary storage and secondary storage. So the primary storage is also known as the main memory and its external storage is not directly accessible by the CPU. The data of secondary storage needs to be brought into the primary storage before the CPU can use it. Secondary storage contains a large amount of data permanently. Fourth one is the arithmetic logic unit. So it calculates related to the computer system are performed by the arithmetic logic unit. It can perform operation like addition, subtraction, multiplication, division, etc. The control unit transfer data from storage unit to arithmetic logic unit. When calculation need to be performed, the arithmetic logic unit and the control unit together from the central processing unit. The last one is the control unit. Control unit, it controls all other unit of the computer system and so it known as a central nervous system. So it transfers data to the computer as required, including from storage unit to central processing unit and vice versa. The control unit also dictates how the memory input output devices, arithmetic logic unit, etc. Next we see the single processor system. So one main CPU which may manage the computer and runs user apps. Other specialized processor such as disk controller, GPUs, etc. do not run user apps. Almost all single processor systems have other special purpose processor as well. They may come in the form of device specific processors such as disk, keyboard and graphics controllers, or on mainframes they may come in the form of more general purpose processor such as IO processor that moves the data rapidly among the components of the system. All of these special purpose processors run a limited instruction set and do not run user processors. Multiprocessor systems have two or more processors in close communication, sharing the computer bus and sometimes the clock, memory and peripheral devices. So the advantages of multiprocessor system is the increased throughput. It is faster execution but not 100% linear speed up. Next one is the economy of scale. Peripheral disk memory is shared among processors. Increased reliability. So failure of a CPU slow system does not crash it. Redundant processing provides system of checks and balances NASA. Another type of multiprocessor system is a cluster system. So cluster system differ from the multiprocessor. Clustering is usually used to provide high availability services. That is, services will continue even with one or more services in the Cluster fail. Clustering can be structured asymmetrically or symmetrically. In symmetric clustering, one machine is in hot standby mode while the other is running the applications. In symmetric clustering, two or more hosts are running application and are monitoring each other. This structure is obviously more efficient as it use of the available hardware. We come to the end of the session. I hope you enjoyed this session. Thank you.